Hi everyone, this video is talk about understanding the structures of sentences. So here are the contents. 1. Introduction. 2. Coping with structural ambiguity. 3. Early work on parsing. 4. Processing structural ambiguity. 5. Gaps, traces, and unbounded dependencies. 6. The neuropsychology of parsing. And the last one is the summary. Introduction. So far, we have concern with the processing of individual words. What happens after we recognize a word? When we access the lexical entry for a word, two major types of information become available. Information about the word's meaning, information about the syntactic and thematic roles that the word can take. Imagine you're reading a sentence. Your brain doesn't just see a bunch of letters. It recognizes those letters as words. Once it knows a word, it does two important things. 1. It figures out what the word means. For example, cat means a furry animal with whiskers. 2. It figures out how the word works in a sentence. For example, cat can be the subject. The cat sat on the mat, or the object, I saw a cat. These two things are like the two sides of a coin. You need both to understand the sentence properly. The next one, think of thematic roles like labels that tell you the function of each word in sentence. The agent, the person doing the action, is Jamboy. The thing being acted upon, the ring. Recipient, the person receiving the thing, it's Grizel. The verb give is like a blueprint that tells us how these roles fit together. It says, agent gives theme to recipient. So, by looking at the verb, we can easily figure out who did what to whom. So here, parsing is like building a sentence. You first look at each word in the sentence and figure out what kind of word it is, like noun, verb, adjective, etc. You then combine these words into groups called phrases. For example, Jamboy gave is a verb phrase and the ring is a noun phrase. Finally, you put all the phrases together to understand the whole sentence. You figure out who did what to whom, and you understand the meaning of the sentence. Parsing is like a step-by-step process that helped us understand the structure of a sentence and its meaning. For the next one, English is a language where the word matters a lot. It's like a puzzle where the pieces have to be in the right place to make sense. Other languages like German or Arabic are more flexible. They use endings, inflections to show who's doing what, so the word order isn't as important. The next topic is all about coping with the structural ambiguity. In here, the newspaper headline "Police Seek Orange Attackers" is ambiguous because it could be interpreted in a few different ways. The problem is that the sentence is written in a way that makes it unclear which interpretation is correct. This is an example of a structural ambiguity, where the way the sentence is put together creates multiple possible meanings. These examples show how important it is to write clearly and avoid ambiguity, especially in news headlines where information needs to be conveyed accurately and quickly. Next is, it discusses the challenges in understanding the operations of processor, especially when everything is working well. As a result, most research on parsing has focused on syntactically ambiguous sentences, which are sentences that can be interpreted in more than one way. Ambiguity makes it difficult for the processor to understand the meaning of the sentence. These examples provided illustrate this point. In the first sentence, old men and women lived first. It is unclear whether old men or men and women are living first. In the second sentence, Boris said that Vlad finished it yesterday. It is unclear whether Boris said something yesterday or Vlad finished something yesterday. The third sentence, I saw the Alps flying to Romania. It also ambiguous. It is unclear whether the speaker saw the Alps physically moving to Romania or if they simply saw the Alps in the sky, which is mountain range. The passage suggests that our intuitions cannot be relied upon to understand the meaning of ambiguous sentences, as psychology has shown that we often miss alternative interpretations. Next, this tells us that our eyes aren't just passively scanning the words, they actively involve in understanding the sentence and resolving ambiguity. By studying eye movements, researchers can gain valuable insights into how our brains process language and make sense of complex sentences. The next one, this model is called serial because it works step by step, and autonomous because each step is independent of the others. It's a way of understanding how our brains might process language, starting with the grammar and then checking for meaning. The second one, this model is called parallel because it works on all possible structures at the same time, and autonomous because each structure is built independently of the others. It's a way of understanding how our brains might process language by exploring multiple possibilities simultaneously and then selecting the best one based on meaning. The third one, these interactive models show how our brains might use meaning to guide the process of understanding language, making it more efficient and accurate.
Now let's talk about early work on parsing. Early work on parsing. Early parsing models were heavily influenced by Noam Chomsky's theory of generative grammar. This theory proposed that sentences have an underlying deep structure that represents their meaning, and the surface structure, which is the actual form of sentence. Here are the parsing steps. In example, the cat chased the mouse. First step is the perceptual data. We see the written words the, cat, chased, the, and mouse. In recognition and lexical access, we recognize each word and access their information. In the sentence, the cat chased the mouse, the word the is determiner, cat is a noun, chased is a verb, the is determiner, and the word mouse is a noun. Third step is the syntactic analysis. We build a parse tree, and the last step is the semantic analysis. We understand the meaning, which is the cat is the subject performing the action, chased is the action, and the mouse is the object of the action. The sentence conveys the idea that a cat pursued a mouse. The units of parsing are the constituents of a sentence. These are the building blocks that make up a sentence, and they can be of different sizes. First is the sentence, the largest unit of parsing. It is a complete thought containing a subject and a predicate. Next is the clause. It is the smaller unit within a sentence. It also contains a subject and a predicate, but it can be a part of a larger sentence. For example, because I was tired is a clause within the sentence. Because I was tired, I decided to go to bed. The clause demonstrate effect and incremental processing demonstrate that our language comprehension is a dynamic and efficient process. We don't passively absorb information. Instead, we actively construct meaning in a step-by-step manner, focusing on the current clause while simultaneously integrating into a larger understanding. Parsing strategies based on surface structure cues. Example: the cat chased the mouse. The surface structure of the sentence often provides a number of obvious cues to the underlying syntactic representation. One obvious approach is to use these cues and a number of simple strategies that enable us to compute the syntactic structure. Examples: when we see or hear a determiner such as the or a, we know a noun phrase has just started. Word order is variable in English, and transformations such as passivization can change it. A common structure in English is SVO or subject, verb, object, and in most sentences, we hear or read the first noun is the subject and the second one the object. In fact, if we made use of this strategy, we could get a long way in comprehension. We try the simpler strategies first, and if these do not work, we try other ones. Kimball's work on parsing is a significant contribution to our understanding of how humans process language. He proposed that surface structure, the way a sentence is actually written or spoken, provides crucial cues for uncovering the underlying syntactic structure. the grammatical relationships between words. Principle 1. Parsing is top-down, except when a conjunction such as "and" is encountered. This principle describes a key aspect of top-down parsing, a method used in a natural language processing or NLP to analyze the grammatical structure of sentences. It means that we start from the sentence node and predict constituents. Example: if you see that the first word of the next constituent is "an", then you know that you are parsing a noun phrase. The right association principle is a fundamental concept in syntax, explaining how we process and understand sentences. Example: Vlad figured that Boris wanted to take the pet rat out. The principle suggests that we attach "out" to the verb take rather than figured, creating the phrase "take out". This principle explains the preference for right-branching structures in English and helps us understand why certain sentence structures are easier to comprehend than others. It is also a key element in the study of syntax and plays a crucial role in our ability to communicate effectively. Let us now move on to processing. One of the major foci of current work on parsing is on trying to understand how we process syntactic ambiguity, because this gives us an important tool in evaluating alternative models of how the syntactic processor operates. There are two models of parsing. Number one, the garden path model, which is an autonomous two-stage model. Number two, the constraint-based model, which is the interactive one-stage model. The garden path model of parsing explains how we understand sentences, especially those with ambiguous structures. It's called garden path because it describes how we initially follow a path that leads us astray, only to realize later that we need to backtrack and revise our understanding. Example: the horse raced past the barn fell. According to the garden path model, parsing takes place in two stages. Number one, the processor draws only on syntactic information. If the incoming material is ambiguous, only one structure is created. Number two, if the syntactic structure chosen in stage 1 is still implausible, then a second pass is necessary to revise the parse tree depending on other information: semantic, pragmatic, semantic, and even syntactic. Constraint-based models of parsing. In constraint-based models, the processor uses multiple sources of information, including syntactic, semantic, discourse, and frequency-based, called constraints. The construction that is most strongly supported by these multiple constraints is most activated, although less plausible alternatives might also remain active. Processing syntactic category ambiguity. Lexical category ambiguity. One type of lexical ambiguity that is of particular importance for processing syntax is lexical category ambiguity. Lexical category ambiguity is a type of lexical ambiguity where a word can be from more than one syntactic category, example, a noun or a verb, as in dreams or watches. This type of ambiguity provides a useful test of the idea that lexical and syntactic ambiguity are aspects of the same thing and processed in similar ways. Processing syntactic category ambiguity. Lexical category ambiguity according to serial stage models. According to serial stage models such as garden path theory, lexical and syntactic ambiguity are quite distinct, because lexical representations are already computed, but syntactic representations must be computed. According to Frazier, distinct mechanisms are needed to resolve lexical semantic, syntactic, and lexical category ambiguity. Lexical semantic ambiguity is resolved in the manner where the alternative semantic interpretations are generated in parallel and one meaning is rapidly chosen on the basis of context and meaning frequency. Example: I went to the bank to withdraw some money. In lexical semantic ambiguity, the word bank can refer to a financial institution or the edge of a river. The context withdrawing money quickly disambiguates the meaning, favoring the financial institution interpretation. While in syntactic ambiguity, the horse raced past the barn fell. This sentence is ambiguous because race past the barn could modify either horse or fell. Lexical category ambiguity refers to words that can belong to multiple grammatical categories or parts of speech. For example, train can be a verb to train or a noun a train. The delay mechanism is the clever strategy our brains use to efficiently resolve lexical category ambiguity by delaying the selection of a specific meaning until sufficient contextual information is available. Constraint-based theories offer a flexible and dynamic approach to understanding how we process ambiguity. They emphasize the interplay of multiple sources of information, including context and word frequency, in guiding our interpretation.
Gaps, traces, and unbounded dependencies. Syntactic analysis of sentences suggests that sometimes constituents have been deleted or moved. Compare 1 and 2. Vlad was selling and Agnes was buying. Number 2, Vlad was selling and Agnes buying. Nothing is deleted or moved in number 1. 2 is perfectly grammatically well formed. The verb was has been deleted to avoid the repetition, but it is still there implicitly. Its deletion has left a gap in the location mark. Gap is a position within a sentence structure where something appears to be missing in comparison with most other typical sentences. Trace is a special type of gap caused by the movement of a constituent in a sentence to another position in the same sentence, such as the trace in number 2. So when we say gaps, it is sentences where words are missing, but we still understand the meaning. These gaps are often created when words are moved to different parts of the sentence or left out to avoid repetition. And trace is a special kind of gap created when a word is moved, leaving a mark where it used to be. Another example is, which sword is sharpest? Number 4, which sword did Vlad sharpen yesterday? There is no trace in number 3. In number 4, sharpen is a transitive verb demanding an object. The object sword has been moved, leaving a trace indicated by T. This type of structure is called an unbounded dependency. Unbounded dependency is a situation where closely associated constituents are separated from each other and can, in principle, be infinitely far apart. In sentence 4 shows a trace where the word sword has moved. This movement creates a long distance between the word and the verb it's connected to, which is called an unbounded dependency. It's like the words are linked even though they're far apart. Which sword did Vlad sharpen yesterday? Gaps and traces may be important in the syntactic analysis of sentences, but is there any evidence that they affect parsing? If so, the gap has to be located and then filled with an appropriate filler. Here's word. The WH movement construction in number 4. So when a word is moved in a sentence, like sword in number 4, our brains still understand that it belongs with the verb sharpen. This is because we mentally fill in the gap where the word was moved from. This process of finding the gap and filling it is called parsing. How do we parse traces? There is some evidence that we fill gaps when we encounter them. First, traces require relying on memory. The dislocated constituent has to be held in memory until the trace is reached. Which sword did Vlad sharpen yesterday? Number 2, processing of the trace can be detected in measurements of the brain's electrical activity. So when words are moved around in a sentence, our brains have to work a bit harder to understand them. This is because we need to find the gap where the word was moved from and mentally fill it in. This process of figuring out the sentence structure is called parsing. Number 3 on how do we parse traces. All languages seem to employ a recent filler strategy whereby in cases of ambiguity, A gap is filled with the most recent grammatically plausible filler. Example, this is the girl the teacher wanted T1 to talk to T2. Another example is this is the girl with the teacher wanted T to talk. Fraser, Clifton, and Randall 1983 noted that sentences of the form of 5 are understood 100 ms faster, as measured by reading times, than sentences such as number 6. There are two possibilities. One possibility is that when the processor detects a gap, it fills it with the most active item and is prepared to reanalyze if necessary. This is the active filler strategy. In 6, it is the girl that should go into the gap A, and not the most recent constituent, the teacher. This delays processing, leading to the slower reading times. B. Another possibility is that the processor detects a gap and fills it with a filler that is the most recent, potential dislocated constituent. This is the recent filler strategy. In 5, the constituent, the teacher goes into the gap T1, leaving the girl to go into T2. These two strategies can be quite difficult to distinguish, but in each case, trace detection plays an important role in parsing. Imagine a sentence like, which book did you read yesterday? The word book is moved to the beginning, leaving a gap marked by T. When we read this sentence, our brains remember the word book and automatically fill in the gap with it, even though it's not directly next to the verb read. It's like our brains are doing a little puzzle figuring out where the missing pieces goes. Brains use a recent filler strategy to understand sentences with gaps. This means we fill the gaps with the most recent grammatically plausible word or phrase. It also makes understanding sentences faster, but sometimes it can lead to a delay if the initial filler is incorrect. The neuroscience of parsing. Parsing can help us understand brain damage. However, deficits in parsing might not always be apparent, because people can often rely on semantic cues to obtain meaning. The deficit becomes apparent when these cues are removed and the patient is forced to rely on syntactic processing. There is some evidence that syntactic functions take place in specific, dedicated parts of the brain. Evidence from this comes from differing effects of brain damage to regions of the brain such as Broca's and Wernicke's areas. So, it can damage to specific parts of the brain can affect our ability to understand how sentences are put together. The comprehension abilities of agrammatic aphasics. Grammatism. Agrammatism is the disorder of syntactic processing that follows damage to Broca's area, which causes impaired speech production and difficulty in understanding syntactically complex sentences. Features of agrammatism. A. Inability to process trace and fillers. B. Poor understanding of reversible passive constructions in the absence of semantic cues. Example, the dog chased the dog. The cat was chased by the dog. C. Poor understanding of object-relative constructions in the absence of semantic cues. Example, the cat was black. The cat that the dog chased was black. When we say agrammatism, it is a language disorder caused by damage to Broca's area. People with this disorder struggle with understanding complex sentences, especially those with move words or unusual structures. Agrammatism also have evidence. First is disruption of parsing ability or trace deletion hypothesis. One explanation for these people's difficulty is that brain damage has disrupted their parsing ability. These patients are unable to access grammatical elements correctly. This can be seen in their A. Inability to process traits and fillers. B. Poor understanding of reversible passive constructions in the absence of semantic cues. C. Poor understanding of object-relative constructions in the absence of semantic cues. This difficulty arises because syntactic traces are not processed properly, and the terminal nodes in the parse trees to correspond to function words are not properly formed. Grodzinski 2000 spelled out the trace deletion hypothesis. This hypothesis states that people with an agrammatic comprehension deficit have difficulty in computing the relation between elements of a sentence that have been moved by a grammatical transformation and their origin or trace, as well as in constructing the higher parts of the verse. Number 2, computing the constituent structure of a sentence vs. using the information. So in number 2, when the people with agrammatism can spot grammatical errors, suggesting they understand sentence structure, however, they struggle to use this knowledge to understand the meaning of complex sentences. Number 3, impairment of general memory. This theory proposes that problems understanding grammar in people with language impairments are not due to a specific grammar issue, but rather a general memory problem. Example, imagine you're trying to solve a puzzle while juggling. The more juggling balls you have, the more memory load, harder the puzzle becomes. People with this language impairment are like those juggling lots of balls. Their brain is overwhelmed, making it hard to understand complex sentences even though they know the grammar rules. Number 4, global reduction in computational resources. Number 4, people with agrammatism often report feeling overwhelmed by fast speech. As if their brains lack the energy to keep up. This suggests a limited capacity for processing information, like a battery with limited power. Slower speech, on the other hand, can improve comprehension. This is because it gives their brains more time to process the information, allowing them to use their limited resources effectively. It's like giving their brain's battery a chance to recharge. This suggests that time constraints play a significant role in their difficulty with language. They need more time to process complex sentences as if they are working with a slower processor.
And the last one is summary. The clause is an important unit of syntactic processing. In autonomous models, only syntactic information is used to construct and select among alternative syntactic structures. In interactive models, non-syntactic information is used in the selection process. Psycholinguistics have particularly studied how we understand ambiguous sentences such as garden path constructions. One of the most studied types of garden path sentence is the reduced relative, as in the well-known sentence, "The horse raced past the barn felt." Early models of parsing focus on parsing strategies using syntactic cues. Kimball proposed 7 surface structure parsing strategies. The garden path model of parsing is still a 2-stage model, where only syntactic information can affect the first stage. In constraint-based models, all types of information, thematic information about verbs are used to select among alternative structures. In constraint-based models, lexical and syntactic ambiguity are considered to be fundamentally the same thing and resolved by similar mechanisms. Some aphasics shows difficulties in parsing when they cannot rely on semantic information. There is no clear neuropsychological evidence that content and function words are processed differently in parsing. And that's all. Thank you!